Okay, here we go. Make sure we have sound. We're live. All right. Particle moves along the x-axis. Okay, that is not new. You've done a lot of problems dealing with particles moving along a line. I don't like to think of it as the x-axis, however. It's just a line. The origin of the line is always the center. Origin does not mean where everything begins. It's just the middle of the line. They give us a formula for velocity. I'm always paying attention to what do they give, what do they want. What do they give me, what do they want? Here we go. Particle is at position 2 at time 0. You need to be able to translate the English sentence to a mathematical equation. Hands up. What's the equation? What's the equation that says this? Particle is at position 2 when time is 0. What's the equation? Hands, come on. Got to be able to do this. We've got to get quicker. The test, you don't want to move fast on the test, but you do want to move along. Okay? So, I get somebody new here. Let's go, Logan.
2 equals 0.
We'll use x in this case. Maybe that's what you said. X of, other way around. X of 0 equals 2.
Sorry.
No worries. How many knew it? 0.2 for Logan. Question. Keep reading. What is the position of the particle at time equal 1? I want to translate that into a math sentence, math equation. Hands up. What do I write? How do I write that using math symbols? So Isaac?
It's just x of 1 equals...
Whatever, yeah. That part I don't know, so. How many knew it? 0.2 for mine. Sorry, Isaac. Question. Okay. Look, golden notes. Most important box on the golden notes right here. They're giving you a rate. Velocity is the rate at which position changes. They're asking for an amount. They want a position. Therefore, fundamental theorem. So come back to here. I write down the fundamental theorem as it applies to this problem. I want to integrate from time 0 until time 1. Velocity think with me, don't watch. Hands up. What do I write down? What do I write? Now, using the fundamental theorem, what is that integral going to have to equal? 0? There you go. Whenever I integrate a rate, I find a change or difference in the amount. It's on your golden notes. Right here is a section that would be very important to pay attention to. Starting here, they're all grouped together. These are all ideas associated with fundamental theorem of calculus, right there. Okay, nothing on the test is tested more heavily than that little section. Counted one time, fully 1/3 of all points available on the AP test came from that little box. So you get good at that box, you're on your way. Please.
Just on this school note, what is the big F, the capital F?
Gotcha. So, 2 for Logan. Capital F is not a standard symbol, meaning like F prime is a standard symbol. Wherever you see it, it means the derivative of small f. On the AP test, however, they commonly will do something like this. They'll say capital F is the antiderivative of little f. Does that make sense? So that's not standard. They'll tell you. They tell you so much that I thought it was actually useful on the golden notes. Start using capital F just to kind of remind you that that usually happens. Does that answer your question? 2 more. Anybody else? Cool. Back to the problem? Okay, so I'm all set now. I have, I'm trying to find x of 1, so I just rearrange. Therefore, x of 1 must equal x of 0, which is 2, plus the integral from 0 to 1 of the velocity. And the velocity is 3t squared plus 6t. Like that. I don't have a calculator, so I can't actually integrate. So instead, I find the antiderivative and evaluate. So x of 1 will equal 2 plus parenthesis 3t cubed over 3. Oh, they were nice. The 3's divide out. 6t squared over 2. They were nice again. 6 and 2 divides. They were nice again. One of the values is 0. Okay? AP test is all about one step at a time. You don't know where you're headed. You just have to take one step and then another, and pretty soon it all comes together. Question? Please.
Instead of like doing limits and stuff, can you just immediately take b of t and go do the antiderivative of it and then set, because you know it's at 0 x equals 2, and then you can set c equal to 2. Can you, I mean, solving it that way, it looks like it works.
Yeah, let me summarize what you're saying. 2 for Carl. This problem, kind of like the one I talked to Zarin about, it does have 2 methods you can use. I wouldn't say one is better than the other, they're just different. I tend to emphasize the fundamental theorem method because that method shows up in a lot more problems where the other method doesn't. But the other method is valid. You can find the antiderivative of this. You'll end up with whatever plus c. You then use this information to find the value of c. That creates an equation for x of t, which allows you then to plug into that equation 1 and get the same answer. It's perfect. There we go. So if I were to keep going here, you'd have 2 plus, plug in the 1, plug in the 1 again. I don't have to plug in the 0 because the result would have just been 0. So my final answer is 2 plus 1 plus 3. Question? We have a different question we can help you with. Make sure that you're going to get a better score on the practice test. I'm going to